Hello, everyone. Welcome to the wasmCloud community meeting for Wednesday, December 20th. Normally whenever we have a new community member join the call, we like it if they do an introduction. And so I just want to welcome Buddy the Elf for joining wasmCloud community call for the first time.
Hey everybody. Just want to
Um,
call in from the North Pole where we use wasmCloud to build toys for all the boys and girls around the world.
Amazing. Yeah, Buddy, I can't wait to hear a little more about your use case. You started some discussion, hopefully a certain special someone from the North Pole will agree to open sourcing the factory actors and capability providers. All those things should be fun. Okay. Um, all all fun aside, as we start the call, we've got a pretty quick meeting today. It really shouldn't it'll be a demo which will hopefully spur some good discussion. But I'm sorry. I'm still loving the buddy inclusion in the community call. Okay, we're gonna talk a little bit about our out of the box experience with the WASI APIs for Rust and TinyGo. This is something that I've been working on this week, something that I've been looking at for our documentation for wasmCloud. And I just want to kind of share this broadly with the people on the community call and in Slack, and then eventually in documentation and in a blog post, of course. But what I want to talk about is essentially the new Hello World in the wasmCloud ecosystem. Because we talked for a while about this notion of having complete component support in wasmCloud. And we actually, you have been able to build components for a while and run them in wasmCloud and use WASI APIs. But the difference is now we are going to be pushing the user experience, the developer experience to be components first. So instead of building WebAssembly modules and using the wasmbus ABI to communicate back and forth with actor components and capability providers, we're going to use WebAssembly components fully for that as much as we can. And that ultimately gives us the flexibility of using the common standard. So library implementations are all going to be done with that common standard. And to reuse, essentially hook into the common ecosystem there. Now, let's see. There was one PR I wanted to try and pull up. Apologies that I'm not exactly sharing this because it's in the background, but I wanted to call out. Where is it? Hmm, maybe close. I'll find it a little bit later. I know that Wasm Time 16 is not officially released yet, so we were working with essentially a release candidate, but it is in the pipeline and should be releasing very soon. So, from a components first approach to writing a wasmCloud actor component, it all when you use the like basic WASI APIs, it all kinds of starts with this WIT world. So this is where you can define all of your imports and your exports to your WebAssembly component. And for a hello world type example, where we're going to be taking in an HTTP request and responding with hello world, we can export this one function called WASI HTTP incoming handler. So just like before, where we would have a trait in Rust where we implement a function called handle request. And so that's like dealing with giving you an HTTP request and you get back a response. We're doing the same thing just with the official WASI HTTP interface. And if we look at that with specifically under HTTP handler, the incoming handler interface has just a single function called handle, and that takes in a request, and then it has a response out param, which is a little bit different, but essentially you write your HTTP response to that out. And so the bare minimum, what this actually looks like in Rust, and I'll start with Rust, and I'll also talk about TinyGo too because I have both of them. looks like this. And so what we have is we're using the WebAssembly crate to generate types based on the interfaces that we depend on. And we're exporting this one WASI HTTP incoming handler. And then we're importing or we're using a couple of types here. And then the function signature looks really similar to what we have before or what we would have in any like kind of function as a service style framework where you have your essentially handle request function. And so all we do using the WASI HTTP types is create an outgoing response. We write a couple of bytes to that response body. So, we're saying hello from Rust, and then we finish processing that and set the outgoing response to the response that we created. And so you can take this component. This doesn't have anything. If we take a look at the cargo.toml, the only dependency is WebBindgen. So you can do one of two things. You can build it specifically using cargo. So you can cargo build for target wasm32 WASI. And then once you've done that, you can use the WASM tools. I think I have it here. I want to show just for edification. You can use the WASM tools component new functionality with that HTTP hello world and output a component with that. Now, this does require that you adapt it with an adapter, and this is all kind of lower level details if you're just building this on your own. So we highly prefer using wash build, and wash build essentially wraps up this step of building for wasm32 WASI, creating a WebAssembly component out of it, and then signing it with our wasmCloud ecosystem things. Now, there is a way that we can make this a little bit better using the cargo component tool. The cargo component tooling will be a little bit nicer of an experience for this just out of the box. But that is something that is constantly being updated, but we plan on pulling that into Wash as soon as that's viable. Kevin, hand up.
Yeah, two questions. When you did the -- adapt on WASM tools, does that just sort of automatically go figure out where the preview one WASM file is, or did you actually have to pass it as a parameter?
Yeah, you do have to pass it as a parameter. Actually, just like Control C that one because I don't have the adapter anymore.
Okay, so my first question was, do we still need the preview one adapter WASM? And the answer is yes, we do, but wash build hides that for you.
Exactly.
Okay, yeah. And then second question is, which version of WASM time makes this particular demo or this functionality possible?
16.
Okay, so it's still just 16 that does it. There isn't a newer one.
Yep. Yeah, 16 actually isn't technically released yet.
Okay.
But we were kind of getting all these together for this is all of this, like the wash build and the wasmCloud version that we're using off of main is a release candidate. Because we're just waiting for wasm time 16 to drop essentially. Yeah, Taylor.
Just a couple notes. I'm channeling my inner Bailey since Bailey is not here right now. Just to call it out. So we are pinning on wasm time 16, and then we'll have ways of like moving forward with the next versions as things keep getting added. But then the other thing to note is that soon, I know that at least in Rust, like I think Alex Crichton is the one working on adding basically preview 2 as a target, and then you won't have to adapt anymore. So the adapt step will be slowly going away as languages add support for basically the WASI preview 2 target. But right now, like Brooks was saying, it gets wrapped away for you inside of Wash, so you don't have to worry about it, or if you use a tool like Cargo Component.
Yeah.
I don't know if this is
no, my bad, Kevin.
If this is a rabbit hole, feel free to pass on it. when you use wasmTime 16 and wasmCloud is supporting things like WASI messaging or whatever, one of the standard WASI interfaces. Is that something that wasmCloud is doing just using regular wasmTime 16, or are you forking stuff in order to make that happen?
Yeah, that's a great question. We are just building directly on top of wasmTime 16. I can see if I can find where it is specifically in. I'll look for just a minute, and then if it takes too long, then I'll drop it. But essentially, what we do is we don't fork wasmTime, but we do take wasmTime and use its regular inputs, or sorry, imports and exports, which is things like IO, WASI CLI, WASI, what's the other one?
So
WASI.
again, if this is going to take too long to find it, but is there a spot somewhere I can look to see how you're adding support for things like the the other components like messaging and KV and stuff like that to the wasmTime host?
Yeah, I would take a look at this runtime crate inside of wasmCloud. Under that wit directory, the host imports, or like this host.wit is essentially everything that a wasmCloud component can export and that we can handle um, on the wasmCloud side. All of
Okay,
these
cool.
things plus the regular WASI, like WASI CLI, standard error and things here, actually, because those are just handled by wasmTime itself. We kind of get those implicitly.
Yeah. So there's two worlds here. The host wit and the guest wit. Host wit is the stuff that they can import from the host and consume, and then there's stuff that they can export by default. That's like the guest side, and then all the implementations are inside of this runtime folder. So
Okay, cool. Thanks.
Aha. Well, there's some of it. Yeah, this would be a good place to under the actor component. Okay, so I wanted to show off once we have built this component and it's signed and everything, we can use the nice new wash inspect wit to take a look at this component's at the end of the day, the component's wit. You can see that in bringing in WASI HTTP, our official, WIT, what we're specifying is that, hey, we need to export the incoming handler. And then some of the other things in WASI HTTP proxy brings in things like outputting to standard in, standard out, all of those things. And this set of functionality is actually all included within wasmTime's serve function. So something that was really important to me when writing these initial examples is that they work in wasmCloud and they work just with, you essentially can have this measure of, hey, this is supported just by like basic WASI APIs. So we built this wasmCloud component, but we can serve it with the wasmTime serve function, which is built kind of for WASI HTTP. We can serve this specific component, and this -s common tells wasmTime to load the set of exports that will essentially support all of these things: WASI IO, WASI CLI, WASI clocks. Essentially the common WASI APIs in addition to just WASI HTTP. So when we serve that, I guess I need another terminal. We can curl localhost 8080. We get hello from Rust. So we just built this component using the wasmCloud tooling, and we ran it in wasmTime. Now, what this looks like to run in wasmCloud is we have something like we have a Wadum manifest. I don't know why I'm editing that there. Getting too used to them. We have a Wadum manifest. And so what we can do, I'll use wash build just to keep this easy. We can take this path to the actor and we can replace that here in the Wadum. And then so we have our hello world actor, which is pointing to this component. We're going to run it locally on port 8081 and link that to the HTTP server at runtime. So I can run wash using wash up. I'll just run that in the background to keep it easy. I might have actually kept a application manifest around from when I demoed this before. So we'll kill that if so. Take a look at our apps. Yep, there it is. App Del. Okay, so if we take a look at our host inventory, see what's running, nothing running yet. We can deploy this application. So it'll deploy that component in the HTTP server provider and link them together. Give it app list. Okay, still working on it. Actor has started. Here, there's a smarter way to do this. Nice. We'll give my HTTP server provider just a minute to wrap up downloading and all of that. So essentially, we're taking the same component that we served with wasmTime and getting it to run in wasmCloud. That's already running. It's already instantiated and everything. But to get that HTTP request to the actor itself, we need the HTTP server provider. So even though this is using the kind of standard handler, this WASI HTTP incoming handler is something that will invoke whenever it gets an HTTP request from a capability provider. Okay, so we got that. We got a couple listeners spun up, but if we curl localhost 80, not that one, 8081, we get hello from Russ. This time it's coming from wasmCloud. And so everything works exactly the same. And this is exactly the experience that we are going for. The same exact process works for TinyGo. If we take a look at that Hello World WIT, it's the same. This is kind of the goal for all of our examples, is that once we do it in one language and we have a WIT, we can recreate it in a different language really easily. And if we take a look at the Go file, things are going to be actually really similar. The lines of code, other than, I do some nice things here to alias some of the requests because they're specifically versioned with a release candidate and everything. I think that's what makes it a really long type. But we have an HTTP server struct. We set our incoming handler to be, or the thing to handle an incoming HTTP request to that struct. And then we're doing the exact same thing in this handle function. So we create an HTTP response. We write hello from Go to the body and then finish that response. So if I go to our, if we got to our Golang example here, we can do the same thing. We can run wash build, and that will go through the TinyGo process of generating the interface using Go generate, compiling using the TinyGo toolchain, and then signing it. We can, again, do the same thing with wasmTime serve under build. And this time, I'm losing track of all my terminals. This time, if we curl localhost 8080, that might be actually handled by, hold on. We'll stop our wasmCloud host because we're not using it anymore. We can serve that. We can curl 8080 and we get hello from Go. So this is really, I really wanted to show this example working, both of these examples working. They're up in the wasmCloud repository now. Kevin, you asked earlier, but just to show, the wasmTime version is wasmTime 16. This is going to be a really cool way to start working on wasmCloud applications. Now, I wanted to talk about a couple things here because I would argue that this method of working with HTTP fundamentals is a little bit lower level than we ideally want for a wasmCloud application developer. Like when you're working in the world of application development, usually the lower level of primitive for an HTTP server, like our abstraction that we have currently with receiving an HTTP request and then just returning an HTTP response, is the level of abstraction that I expect from an application framework. This notion of like writing out a response body and creating that using the specific generated code from WebAssembly is a little bit lower level than we want. And that's actually okay. Like that is the purpose of WebAssembly, is to create this correct generated code for library users to be able to wrap and use on their own. So as far as looking at the out of the box experience, this is what it is. This is like specifically something that, even if we use a higher level abstraction later, it's going to use primitives like this under the hood. But in the near future, what we really want to do for wasmCloud is to use use a crate to abstract some of this to give application developers a nicer abstraction to work with. So, for example, we have this crate in wasmCloud called wasmCloud Actor. And this is essentially bundling together the WIT interfaces that we support today in wasmCloud, which one gives you a nice touching point to bring in all of the interfaces that you would want to use. So if you want to use key value, you just import it from the wasmCloud actor crate. If you want to use logging, I actually have an example of that one. I'm still working on it, hence the name Other IDK. But what the experience will likely look like is you'll have WitBindgen for generating types from your specific WIT, or if you have your own custom interfaces, and then the wasmCloud actor crate. And what the usage of that will be is as soon as you want to add logging to your application, you can import the log function from wasmCloud actor and then use that directly. Now, this is actually this is what we'll do for our what we call first party supported interface supported languages in the short term. But in the long term, there are two things that essentially make this better that we're all going to be working to. The first one is wasmCloud Actor is just going to be taking the WASI interfaces and putting a nice abstraction on top of it. And so that kind of work is actually something that belongs at the bytecode alliance level. And I'm not saying that we're pushing that work out. It's something that we can actively work on and contribute. But the common language SDK that provides a nice abstraction over WASI APIs is something that we can work together with other people who are working on WASM runtimes on. It's not something that tightly binds you to any specific runtime. So we can work with a really nice level of abstraction in languages that have good support for WebAssembly with compiling and then like the WebBindgen level. The second thing, that is something that we'll probably do here in the near term, something to improve like idiomatic usage of a language. What the the future term, like the ultimate thing that we're working towards, is that library publishers in languages actually add that support in their own library in order to work with these WebAssembly types. So this type of future is not one where in Rust you import an actor, a wasmCloud actor library, or you import a bytecode alliance Rust SDK for working with WASI. It's the world where you create a new cargo project, you add hyper as a dependency. And when you create when you follow the example in hyper's documentation, when you compile to wasm32 WASI, that ends up using all of the hyper library functionality and interacting with WASI HTTP or WASI sockets at the lowest level. So I really wanted to try and lay out, the vision there. That all comes a huge kudos and thank you to Roman and Bailey. I've also talked to Connor and Taylor and other people with in the Bytecode Alliance about this. So I hope I'm conveying the vision properly. But that's something that I'm really excited about. I'm planning on putting out a blog post, hopefully, on the wasmCloud side here pretty soon. And so I'll definitely be looking for more people's thoughts there. Because for as a project, we're going to want to lean into components and provide the best developer experience that we can. I think it's important to keep sight of the long-term goal of people just get to write code in the language of their choice and use the libraries that they are used to using, and then compile the WebAssembly, and then they can run it in a WebAssembly runtime. So lots of stuff there. I talked for a little bit longer than I meant to, but hopefully this is a good. Hopefully this is something that's good to look at. If you're interested in trying the examples on your own, you can take a look at the wasmCloud repo. If you install Wash from main, then that has the support for building these components and running wasmCloud that has wasm times 16 underneath it. So you can do all the things that I did in the demo and see how it feels. We'll be updating our intro documentation to support more of this type of component flow here in the near future as well. Okay. I see yours, you tagged me on something that's driving you nuts. And maybe a couple other questions. What questions you all have?
Yeah, in the God side, like, can I move most of the code from the init function into the main function, or is that a no-go? No pun intended.
Yeah, a no-go. You're talking about from here, you don't like this, you don't like the init function. You like you prefer a main.
Yeah, yeah. Is that possible or no?
If I remember correctly, this init function is actually a special thing in TinyGo. Like TinyGo WebAssembly exposed this like init or start function that you call as soon as you initialize the component. So I think it has to be here, but I'm not totally sure and would
Okay.
defer to Jordan or something for that. Because I think
Yeah.
it might be an assumption from working with modules from a long time ago. Yeah, Connor.
I think you covered this, but maybe worth being more explicit about. So, one thing that we tried to get rid of in the move to components were wasmCloud specific SDKs. And as you were talking about the wasmCloud actor crate, if I use that, is that going to tie me to the wasmCloud ecosystem, or would I still be able to take a component that I built using that crate and run it elsewhere?
Yeah, let me show you. So I've got my other IDK here, and this was basically this morning's experimentation with bringing in the wasmCloud actor crate. So this one does use that crate, and it pulls in specific functionality from this crate, which is the WASI logging log function. So if I run wash build here, this will build and sign the component. If I inspect the wit of this build, this is actually, and I didn't even rename anything. This is actually the exact same world as before, but it includes WASI logging. And that is a little bit of a roundabout way of answering your question, Connor. But to be specific, the functionality that we're exposing in wasmCloud Actor, all of the things under the WASI module are standard WASI interfaces. And as we continue to, as more interfaces get added to wasmCloud, like right now, if we take a look at Actor, we have, where is it? We take a look at Actor. we were using WASI blob store, WASI key value, WASI logging, and WASI random. There is additional functionality that we can use in order to make things work within the wasmCloud ecosystem, like wasmCloud Bus or wasmCloud messaging, which right now is a in-app replacement for WASI messaging, while that interface gets like the kinks worked out, because that's not quite upstream yet. The goal is to provide all of the standard interfaces. And so if you use anything in the WASI world there, it's all compatible with a wasmTime type runtime. Now you will, oh, so Connor, you will notice that if you, because I tried this morning with WASI logging, if you try to serve that that component, wasmTime serve doesn't actually export WASI logging. And so that's something that won't work with the specific helper function, which is built for just WASI HTTP. So I'm working on trying to get an example with wasmTime that this will work out of the box with, but kind of have like a subset of functionality to work with, because that wasmTime serve is really meant for like testing an HTTP handler.
That's great. So even though in my source code I see the word wasmCloud, it's a public crate and it's not injecting anything specific to wasmCloud into the final component. So that seems in line with sorry, I'm being a bad plant today. It seems in line with wasmCloud's stated goal of producing vendor-less components. We're not interested in constructing a walled garden here. This is purely to improve the developer experience. And I think I heard you also mention something about the long-term intent being that this crate would go away, and that since these are all public WASI interfaces, that those helpers would live in upstream crates, and that we just did this for convenience to solve the problem today.
Yeah, exactly. Exactly well said. And something like the wasmCloud actor crate, I think a short-term evolution will be taking that and making it just a like wasmCloud crate, something like that. Struggling to find the exact example. I believe Roman did do a POC with a fork of the hyper crate, which just all it is a Rust project with a main function that sets up a hyper handler and it hooks into the WASI HTTP interface. But that's the eventual goal for sure. I thought I saw somebody else's hand go up, but I can't remember. Maybe not. All right. Well, hey, I really wanted to, I know this is our last wasmCloud community meeting. It's not the last one of the year, but it's the last one before I'm sure a lot of people will be out next week and for the, kind of through the end of the year, visiting family, doing things to celebrate kind of the end of the year and looking towards 2024. So I didn't have any more discussion items planned for today. I'm sure we're going to have a lot to talk about going into the new year. But I figure this is a good time to open it up for everyone. So it could be, this is just free time in the community meeting. Anybody have any questions or comments on WebAssembly landscape, wasmCloud, roadmap? I'll just leave it open for anybody to take the floor.
Related to the HTTP client, does that WASI module allows streaming in the HTTP client?
It does. Yeah. You can stream I'm doing like basically doing the simplest mode of like take these bytes and just block, write, and flush. But you can actually stream those bytes. If you use the outgoing HTTP handler too, you can stream in and out, which is a nice level of optimization and probably put into anything past like the hello world. think actually Victor's example with the HTTP Echo TinyGo has some examples of that, of the streaming functionality. I don't know if lazy is the right word, but I was too lazy to do it in my Hello World. But I believe Victor's actually does have some of that in there. Where is it? Maybe. Victor, do you do
I
streaming
was
in your example?
I was going to say no, actually. So there is a really useful blocking write and flush function. So you can basically sit there and try and pull in the body streaming. Oh, or sorry. So it depends if you mean going in or coming out, right? So you can both take a streaming incoming body and you can stream the request out. But right now, the uh, the example that's in there that I wrote, the echo that sort of takes a request and spits it back out at you, will try and read as many bytes as possible, right, in one request. So it basically just tries to read max, what is that, U 64 bytes or whatever, or untimed 64 bit. Um, Basically as much as you can fit, and then on the way out there's a single sort of blocking write and flush function that we use to write out the body. So we don't actually stream the body, though it technically is always a stream, right? Like when you with the way that the HTTP stuff is written, you sort of get this sort of pointer to a body, you turn that into a stream, and then you write to the thing, right? And you can just do it all at once instead of just chunking and like going through. Um, I did have a bunch of code in there to do chunking, but I feel like it doesn't make sense to expose people to that because basically, like, I don't know, it's the interfaces are set up in the way I think someone very like reflecting the experience of all the people on the BCA and just like how you would make a sort of code that goes from 0 to 100 and back down and does all the complicated stuff and doesn't do the complicated stuff, but like everyone is just like, oh, I just want to throw a string, but they're not doing a string, right? They're giving you a stream, you write into the stream, like you close the stream, you put it back, you do a lot of things, and I figured people shouldn't be exposed to that right away. So, but yes, streaming is there. It's there. If you look at the WASI HTTP stuff, along with the WASI HTTP stuff and the polling sort of interfaces, you'll see exactly how it kind of lines together. I do think it's valuable to have something of an example there. So if you want a better example, we can definitely put one up.
Yeah, I think those Hello World examples, and through our initial documentation too, you'll essentially go through a little of that journey, like adding iteratively, and we'll see how we'll, whatever we can come up with during that experience, we'll try and kind of encapsulate in the wasmCloud actor crate to give a nice nice bit of functionality. Same thing in TinyGo as well. And I know that we've talked a little bit about next language past Rust and TinyGo. And I know I did do a demo of JavaScript a few community calls back. And I have heard of the people, the people who are working on JCO and componentized JS are working on basically turning the node fetch API into something that ends up creating WASI HTTP fundamentals under the hood. And so I think a JavaScript example will be really nice once we can look at something like that. You create your little function for a handler, and then you can choose fetch to make an HTTP request. That's good stuff. And that does work in wasmTime serve. Outgoing HTTP request is supported by wasmTime serve. So I'm kind of constantly trying to play with the best way to iterate on a component, as quickly as possible. And my workflow is essentially boiled down to either having a little script that just runs wasm time serve and then curls the endpoint and then exits, which is really nice, really quick. And using wash dev with a WADM manifest so that you set up all your capability providers. And then anytime you make a change to the file, wash dev will rebuild and reload your component. You can continue testing. So that's at the front of my mind as I'm making this documentation, is that developer iteration loop. I think, uh-oh, going down a little rabbit hole. I think I'm going to try and propose we move wash dev out of the experimental status because it is a really nice experience for working, like getting that hot reload functionality. It's real nice. Yordis.
Is there any WASI testing module? Because that would be really cool in order to prove how beautiful it would be to swap implementation based on programming languages and whatnot and have the spec outside.
This is where I was mentioning in the chat. I wish I had Bailey here because I know she's mentioned something about some people trying this out, but basically, you need less than you would before because you can test the interface, right? So you can just do your things there and expect specific outputs from it depending on what you're trying to do. But like, there's nothing there yet, is the answer.
Yeah. Okay.
I have some pretty pie in the sky ideas that I might save for post community call, just in case I'm completely wrong. But some fun stuff for testing. Connor.
I probably should have brought this up earlier, but since I have you all captive, Brooks, would you mind pulling this my pull request up?
Okay.
So, and I'm just gonna keep talking. So wasmCloud is working really hard on our documentation. I'm gonna own upfront that our docs are not the best, but we are committed to making them better. And one thing that we're working on now is an FAQ page. This is kind of going to be a grab bag of most common questions that we expect to receive over and over, as well as areas in our docs that simply aren't fleshed out properly enough. So some of the content here will be temporary, other will be long-lived. At any rate, if there are common questions that you've had, I would love feedback on this pull request. If you could take a look at what I already have, any mistakes that I've made, or things that I've missed and haven't added. Oh no, I take it all back. I didn't want the feedback. I was just trying to signal. No, I really mean it. Please be kind, of course, but yeah, I think that's all I wanted to say. Help me help you.
Yeah, thanks for being that, Connor. The link is in the Zoom chat, and we'll make sure to get that shared out in the Slack as well. All right, folks. Well, I think we may go ahead and stop the recording here. Thank you so much for coming to the community meeting today. We will see you next week on Wednesday, and it is kind of in the middle of a time where I'm sure a lot of people, like I was saying, are going to be traveling or spending time with family. So I'm sure that the community meeting will be quick. We'll just come in, touch base. Perhaps a specific elf may grace us with his presence again. We will see. But for everyone, have a happy holidays